Hi friends, I'm Sachin Malhotra. Today I'm going to be solving problem 2 for homework 8 for EL6303. In the question we are given n is a Poisson random variable with parameter lambda, and we are also given that is the PDF of the Poisson random variable where the parameter t is given as t1 minus t2, and we are also given that xt is a stochastic process that equals 1 if n is odd in the interval 0 to t and equals to -1 if n is even in the interval 0 to t. Now for simplicity I'm assuming tau is equal to t2 minus t1. So this becomes, now in the first part we have been asked to find the p of xt equals to 1. Now for xt equal to 1 we know that n is odd, so we will only get the odd terms. So this becomes p of 1 plus p of 3 plus p of 5, and putting in the values we get e raised to a minus lambda tau as common, and inside the bracket we get lambda tau plus lambda tau cubed upon 3 factorial plus lambda tau raised to power 5 upon 5 factorial and so on. So this becomes sine hyperbolic lambda tau, and e raised to a minus lambda tau is constant. So sine hyperbolic tau can be written as e raised to a lambda tau minus e raised to a minus lambda tau by 2. So this comes out to be 1 minus e raised to power minus 2 lambda tau upon 2. In the second part we have been asked to calculate the expected value of xt. Now we know that xt is equal to 1 for n is even, when n is even between 0 and t, and for xt equal to 1 when n is odd we have already found out. So let's find for xt equals to -1. So these are the even terms, so these become p of 0, p of 2 plus p of 4 and so on. Now this comes out to be e raised to a minus lambda tau again as a common. Now the values inside the bracket becomes 1 plus lambda tau whole square upon 2 factorial lambda tau raised to power 4 upon 4 factorial and so on. This term becomes cos hyperbolic lambda tau. So solving this, it comes out to be 1 plus e raised to a minus 2 lambda tau upon 2. Now the expected value becomes p of xt equals to 1 into 1 plus minus 1 times p of xt equals to -1. So just putting in the values and solving, I get the expected value as minus of e raised to power minus 2 lambda t2 minus t1, where t2 minus t1 was our tau. In the third part we have been asked to calculate the autocorrelation function for t1 and t2. Now we know that from the definition the autocorrelation function equals expected value of xt1 into expected value of xt2. Now we can also see that if xt equals to 1, then xt2 also equals to 1, since the number of points in the interval 0 to t are odd. So let's put it like this. We know that xt equals to 1 given xt2 is already 1. So for solving this, let's multiply the numerator by p of xt equals to 1, xt2 equals to 1. So this becomes the intersection of p of xt equals to 1, xt1 equals to 1 into p of xt2 equals to 1. So on putting the values, this becomes e raised to a minus lambda tau sine hyperbolic tau, and this is also for the odd term, so this becomes e raised to a minus lambda t2 into sine hyperbolic lambda t2. So just putting in the values and solving, my autocorrelation function comes out to be 1/4 1 minus e to the power minus 2 lambda t2 minus t1 into 1 minus e to the power minus 2 lambda t2. Now in the last part we have been asked whether xt is a WSS or not. Now we can clearly see from parts B and C that expected value of xt is not a constant, and also the autocorrelation function is not solely a function of T1 minus T2 or T2 minus T1. So we can clearly say that it is not WSS.